Okay, now this is the second part of the review. So now we were done until question number 3. So question number 4 is about case structure. This is related to lab number 2. So implement a case structure such that if volume equals to 4, a triangular wave is simulated. It means that if the condition is true, then a triangle will be simulated with frequency 3 and amplitude 2. If the statement is false, for example, if volume is not equal to 4, a square wave is simulated. So how you do it in lab view? You go to the diagram view. So, okay. So first of all, you will go to case structure. You will bring case structure. Okay. And now when you have case structure, you want this continuous operation using while loop. So you will go to the while loop, you will bring a while loop. When you have while loop, immediately you have to choose this second indicator, stop. You will put your condition here, you will put your wave here, and here you will put your graph. So first you will see that volume equals to 4. You will put, this is your condition. So you means you need this operator which is equal. So you go to math, comparison, equal. When you have equal sign, you will click here with the connected with the question mark. Now this is volume. Volume is a variable. Volume. Okay. Equals to constant 4. We put our condition. Now next step is a triangular wave is simulated. You go to the search, you bring wave generator, you put it here. When you have this, you can choose triangle because it's written a triangular wave. Otherwise, you click here, you go here and choose from here triangle. Okay. So the parameters of triangular wave is amplitude is 2 and frequency. So you see here are different dots. So this is amplitude. Right click. Bring amplitude is a constant number. I gave you amplitude 2. So you will put 2 and frequency is 3. 3. Done. Then when you are done until here, you go to the panel view. You bring top here, you bring volume here, and you bring graph. Okay. You put graph here. Then you go to the diagram and bring this. You don't have to put it outside. Always it will be here. And then you connect it here. Done. Now this is done for the true condition. There is another condition which is false. For the false, a square wave should be simulated with amplitude 2 and frequency 3. It means from here I can go to false or I can choose from here. So for false, I need again wave generator. I connect it here. So now how much is my amplitude is 2 and this is a square wave. So choose from here square wave and choose amplitude 2. 2 is a constant number and frequency 3. Done. This is done. Now look, for the true, there is one condition. So you can check it with your statement. If volume equals to 4, a triangle should be simulated with amplitude 2 and frequency 2. Amplitude is 2 and frequency is 3. Okay. And for the false, square wave is simulated with amplitude 2 and frequency 3. Now this is fine. I go here. So what is the true condition? Volume equals to 4. This is true. If I put volume equals to 5, means that is false. For the true, it should make a triangular wave. So let's write true condition should make triangular wave, which is according to the question. Now if I put 5 or 6, this is a false condition. Now this is a square wave. It means my question is correct. You can always cross-verify your answer with your question. So I will see else is always false. So a square wave is simulated with amplitude 2 and frequency 3. So this is false. I put here 6. 6 is not equal to 4. This is a false condition. It plotted square wave. Now I put 4. This is a true condition. For the true condition, it should plot triangular wave with frequency is 3 and amplitude is 2. This is about your this kind of question. So you will put here true condition. How you will put the screenshots? So you will go to the panel, or you can split. So for the true condition is 4, and from here also choose true. You can take this screenshot and you can put it here. Or make a false condition, make 6 or 7 or 8. This is a false condition. And from here select false. So you will put this screenshot. Okay. Then another question is generate a sine wave using math script using start value 0, step size 0.05 and stop value. So this is using math script. So for the math script, we have another method. This is related to lab number 3. Okay. New VI, make it 200. I make it here and make this one like this. Okay, go to the diagram. Now we need what? Math script. So you go here, program flow. From here, you bring math script node. This is your math script. Now math script also has 3 parts. These are the inputs, these are the outputs, and here you write code. For the code, I gave you already start values, step size, and top value. Okay. First of all, I will write start value. Start equals 0. Then step size is step equals 0.0005. Then top value is okay, let's is equals to 10. Okay. Stop value is 1. It's 1. Stop equals 1. Then and the amplitude and frequency, these are the inputs. So you can write here also frequency equals to 5 and amplitude A equals to 3. Or you can give it here also. It's up to you. Input is F and you will choose here create control. This is variable F, or you can write it frequency. Then amplitude, create input A for amplitude, and you can choose amplitude. Then you will remove it from here. Okay. Now I need scale. So for the scale, it will be T equals start, then colon, step, then colon, and stop. Done. Now what is the equation for sine wave? Generate a sine wave. So I will write, let's say I say x equal. So a sine wave has an amplitude A multiplied by sine. Equation of sine is omega t. It's omega t. So what is omega? Omega equals to 2 pi f2 multiplied by pi multiplied by f. And w into t. It will be w multiplied by t. So whenever you have red lines here, you should see if you have error. For example, I didn't put multiply, it was error. So I looked at what is the problem. I have to put static. Now this is done. Okay, now I put inputs, I put the equation, and now I put output. Create output. Output will be t and x. So output 1 will be t and output 2 will be x. Okay, now you have to build cluster here so that you can combine t and x. So you go to here, you go to cluster and build cluster. You put it here, you put it here. Now you need to draw it. So you need graph, you go to the panel view, you bring your components here and you bring graph. Okay, now you go to the diagram and you bring graph here. You will connect it here. Now you go to the panel. How much is the frequency? Frequency is 5 and amplitude is 3. Amplitude is 3, frequency is 5. Run. This is your output. So just you did it according to the question and this is the output. Okay. So you will put it here. Screenshot of the diagram view, screenshot of the panel. So this is about math script. Now this equation, this is the equation you have to solve it using math script. Okay. You can write this equation in math script also. How you can do it? I copied the equation. I go to the new VI, let diagram. This is my equation. It is square root of C plus A multiplied by B square root of. So I will first solve the numerator, then I will solve the denominator. Okay. So okay. First I need what? Square root of C means I need square root. I go to math, I think square root of C. C is a variable, I put C. Plus, I need plus. Square root of C plus A multiplied by B means I need a sorry, we have to solve it using math script, not like this. Okay. So you will go to math script node. Okay. So my equation is, first let's write a numerator, C. Numerator, let's say we say it as x equals, we will write the numerator. Square root is SQRT of C plus A multiplied by B. Okay. Then let's say we have to write D square. So we can say it Y equals D square. D here. Now Z equals x divided by y. Okay. Now my inputs are C, A, B, and D. Create input. It is C, and you will choose variable because there is a table you have different. So this is C, then A, this is A, right click, B, and D, and D. Now these are the 4 inputs, and then output will be Z. And no need for any graph, just choose this variable Z. That's it. Now you go to the panel view. You have C, A, and Z. Now, A is 7, B is 9, C is 4, and D is 9. Run. So this is 0.802. You will write this answer here. 0.802. Then you will put these numbers and then you will calculate. Then you will put screenshot of your program, this one here, and here for the panel, you will put this. Only one case. This is related to this question number 6. Now, next question is find the Fourier transform of the sinusoidal signal. This is your lab 4. This is a very easy question. Okay, how we will solve it? So find the Fourier transform of a sine function. Okay, you go to new VI, make it 200%. Okay, go to the diagram. Okay, I have to make Fourier transform. Okay, for this I need a while loop again. Okay, when you have while loop, press stop. Okay, now for the Fourier transform, I need a wave generator. Okay, I gave in the question amplitude is 1 and frequency is 10. So I will, this is amplitude is 1 and frequency is 10. Okay, now here this will give me output. For the Fourier transform, I will go to analysis, signal processing, measurement, FFT spectrum. I will connect it with this. This will give me Fourier transform. Now I want to see this, how I will see it. I will go to the panel view. I will bring one graph, actually two graphs, because I will plot and I need another graph because I have FFT and I have the time domain graph. So I have two graphs. One graph I will connect here. This will give me time domain signal, and this graph 2, it will give me FFT. You can write here FFT, and this is time domain. And AIN. Okay. Now you go here. Because you have already given this constant amplitude and frequency, you will run. You will see that this is your time domain graph. If you want to see it clearly, you should make auto scale. Right click on the scale, auto scale, 0.1. Only one cycle. If you make 0.5, you will have this cycle, 5 cycles, 1, 2, 3, 4, 5. If you make it 1, you will get 10 cycles because frequency is 10. For this, how I can see, because frequency is 10, I can choose nearest value to 10, but greater value. So choose scale and make it 15. So you can see that your frequency is 10. That's it. You will take it, your diagram view here, panel view here. So this is very simple. Okay. You bring wave generator, you take FFT, you plotted time domain signal, you plotted the frequency domain signal. Okay. This is about lab number 4. Now for lab number 5, I have already uploaded in the Moodle USRP. So you will download that. Then you will go to this is USRP. You will open this project. I will upload it. I have already uploaded it on the Moodle. So you have Rx and you have Tx. Okay. So you will see this table. These are the values for transmitter and these are the values for receiver. Here, this is the samples for the signal. So you will put all these values: 1 gigahertz carrier frequency, 200K IQ rate, and samples is 200K. So you will go here, you will choose your device name, you will put IQ rate 200K, carrier frequency 2 gigahertz, active antenna TX1, and frequency amplitude according to the table. So 200K 2002. This is 200K 2002. That's it. And from it, I don't have device connected with me now, so I will choose from here and run. So this signal will look like this. You have to make the auto scale for this. Right click, auto scale, and choose 0.01. Make it 0.001. Now you can see it. And for this frequency is 2000. So choose some value greater than 2000. Say 3000. Auto scale. This is here. Auto scale. Two hundred thousand. At the moment, it is making a multiple. I don't have my device connected, so that's why it's making problem. But if you have USRP connected, it will be fine. But you have to follow these steps, okay? It is making a multiple. So if you put 1000, it will make 2000. So this is your panel view for the transmitter. Then you will go for the receiver. You will put all these values. Then you will just run. You will receive this signal here. So for this question, it's important that you put these values correctly, all of this, and you should know how to do the auto scale. Okay. So this review. This is the review file. So I will put it on the Moodle also, and I can put all my this files also in the Moodle. This review. So I have all the questions solved here. This also I will put it on the Moodle so that you can practice. And if you still have any questions, send me an email. Okay. Thank you.